In this video, you're going to learn about a new irrational number that's called E. Just like pi is approximately 3.14, the value E has an approximate value that is constant. It never changes. I'm going to show you how to find that value using your calculator. So we're going to turn our calculator on. We're going to go to the main menu, and you're going to hit the Shift button, Shift, and then this LN button, LN. It's right next to the button that says log. So Shift, LN, and you'll see that an E to a power pops up on your screen. If you just want the value of E, you're just going to raise it to the first power and press Enter. And that value is about 2.718. We're going to go out 3 decimal places, 2.718. So we go back here, and that is our value of E. I'm going to write down how we found that. It's approximately 2.718. And we find that by hitting Shift, LN. It looks like IN, but it's LN. It actually stands for natural log. Shift LN, and then raise to the first power. So if I want to graph y equals e to the x, that's very similar to y equals 2.718 to the x power. Now we've graphed y equals 2 to the x power. We've graphed y equals 3 to the x power. Y equals 2.718 to the x power, which is y equals e to the x, this is an e, is going to be somewhere between these two bases. So we're going to make a table. So we already know what this is going to look like. It's going to look like y equals 2 to the x. It's just going to have a slight stretch to it. So I'm going to make a table. I'm going to put a -1 in for x, a 0, a 1, and a 2. Now when I put a -1 in, I'll go back to my calculator. When I put a -1 in, again I have the Shift button, Shift, and then natural log, which is LN. It brings up an e to a power, and I want the -1 power. That's 0. Now I'm going to go to the nearest tenth, 0.4-ish, 0.4. So that would be 0.4. Then when we put a 0 in, e to the 0 power, anything to the 0 power is 1. Then when we put a 1 in, e to the first power is 2.718. We're just going to go out to the nearest tenth, 2.7-ish. And when we put a 2 in, I'm going to calculate e squared. So use your calculator. Now that I've shown you twice how to enter that into your calculator, now compute e squared. And you should get 7.4-ish. Now this is going to have a horizontal asymptote at y equals 0. -1.4 is an ordered pair. 0, 1, 1, 2.7, and 2, 7.4. And like we said earlier, it's going to look just like y equals 2 to the x, but with different points right here because our base is slightly different than 2. Our domain goes from -infinity to +infinity. The range goes from 0 to infinity without including 0. The horizontal asymptote is at y equals 0, and we do have a y-intercept of 0, 1. Okay, how do we use E? Well, as you can see, we can graph it, but more importantly, we use it in what's called the continuously compounded interest formula. And this, I'm going to write this in different colors. We've got A, which is our end dollar value, because we're talking about interest, that's money. So A is our end dollar value in a particular account, and that's going to equal P, which is our initial deposit. We also call that the initial value. We also call that our principal. So we can call it value, we can call it principal. If you think of it as the initial deposit, that works too. And then E is a constant. E is a constant. So it never changes. And then we've got E raised to the R, which is your interest rate. And that's going to be your interest rate as a decimal value, not a percent, times T, and T is our time in years that the money is invested. So what happens continuously compounded means that your money goes into an account and it's constantly making money. So it's constantly earning interest. So you deposit your money, and as soon as you deposit it, it earns interest. And then not only does your initial deposit earn interest, but whatever interest you've earned earns more interest. So the money you make makes more money. Now, you're only going to have an input and an output. So I'd like to go back here. In all of these problems that we did in the previous video, we had an input and an output of X and an output of Y, an input of X and an output of Y. So when I describe this formula to you, it looks like there's many variables. We've got A, we've got P, we've got R, we've got T. But for any given problem, only two of those letters are going to remain. You will only have an input and an output. The other values are going to be fixed, which is called parameters. They're going to be fixed for any given problem. So let's do an example so that you can see. Suppose you invest $1,050 at an annual interest rate of 5.5%, compounded continuously. How much will you have in the account after 5 years? Well, in that first sentence, there's a few things I can highlight. You invest $1,050. There's an annual interest rate of 5.5%. Your money is going to be compounded continuously. And how much will you have in the account after 5 years? I'm going to start with the first sentence, and I'm going to define my variables, and I'm going to write a function. So if I invest $1,050, that's my principal amount. So principal is not a variable, it is fixed for this problem. We invest $1,050 and it's done. The annual interest rate, that's next. Annual interest rate is R, and that's 5.5%. But we need to show that as a decimal, so that would be 0.055. Compounded continuously tells us our formula. That's A equals P times E raised to the RT power. We know that P is going to get filled in, and we also know that R is going to get filled in. So you can see that we've got T left over, and we've got our end value amount left over. So T is going to be the number of years the money is invested, and A is going to be the end value in dollars after t number of years. So we'll have a equals 1050, that's our initial value, times e raised to the 0.055 t power. So this right here is our function. A function has an input and an output, and that's at two variables. Put a value in, get a value out. So you have an independent variable and a dependent variable. Now, how much will you have after 5 years? This is where we'll need our calculators. A equals 1050 times e raised to the 0.055 times 5 power. Now make sure that all of 0.055 times 5 is in your exponent. And when you put that into your calculator, you'll get approximately $1,382.36. It is so important that you make sure that you are able to get that dollar amount on your calculator, that you're not just writing it down, because it can get a little tricky trying to enter this into our calculator. So I will show you 1050 in our calculator, and then shift ln. Now on my calculator, it brings it up into the exponent, but on yours, if you see a little upper caret, you're gonna put a parenthesis and then 0.055 times 5 and parenthesis. Press enter, and we get $13.82.36. So you will round your money to 2 decimal places, and you'll round appropriately. Okay, let's try another. Suppose you invest $1,300 at an annual interest rate of 4.3% compounded continuously. Find the amount that you'll have after 3 years. So what I'd like you to do is make sure you highlight, write the function, and then think about the formula that you're going to use. It says compounded continuously. As soon as you see compounded continuously, you should be thinking A equals, and I say Pert, P times E raised to the RT power. That RT power is only attached to the E. Okay, press pause, and when you're ready to check your answer, come on back and press play. So you should have A equals 1,300 times E raised to the 0.043 T power, where T equals the number of years invested, and A is equal to the end value in dollars after T years. We put a 3 in for T. A equals 1,300 times E raised to the 0.043 times 3 power. And our end value is approximately $1,479. And the 7, that rounded to a 00 cents. So we're going to include that 0.00 because it's important to say that we're accurate to 2 decimal places. Okay, we have another problem. Let's see if you can get this next problem. A student wants to save $8,000 for college in 5 years. How much should be put into an account that earns 5.2% annual interest compounded continuously? Okay, if you press pause and come back, I'm actually just going to give you the work and explain very quickly how to get the answer. You might spend a little bit more time on this one, so really think about what it's asking and the information that you have. Okay, welcome back. You should have seen the compounded continuously and immediately wrote down A equals P times E raised to the RT power. Now, if you want to save $8,000 for college in 5 years, we know that time is equal to 5 years. I'm not sure what that 8,000 is. It doesn't sound like that's what I'm initially depositing. It looks like that's what they're asking us to find. How much should we put into the account? So I'm going to hold on that. I'm going to put the rate is 0.052. If we're looking for P, this value must be the end value, which is 8,000. So I'm going to put 8,000 in for A. I'm going to be solving for P times E raised to the 0.052 times 5 power. Now this is just some number right here. This is P times whatever number this is in my calculator. I can put that into my calculator first, but then I'd be rounding within rounding. So I'm going to do a little algebra. If I divide it by whatever this number is on both sides, and I don't actually do the calculation in my calculator until I'm ready to solve for P, I would get P equals 8,000 divided by E raised to the 0.052 times 5 power. And when I put that in my calculator, I should end up with a number that's less than 8,000, and I get $6,168.41. Now in this last problem, I'm just going to show you or remind you the compounded quarterly formula. The compounded quarterly formula is given right here. On the right, A equals P times the quantity 1 plus R over N raised to the NT power. Now, N is a new value. N is the number of times it's compounded. Compounded means how many times are they looking at your account. Number of times compounded per year. So compounded continuously means that they're constantly earning or paying you interest on your deposit. Quarterly means they're only going to look at your account 4 times per year. Quarterly would be 4 times per year. So we invest 2,000. We invest 2,000. The annual interest rate is 0.045. We're going to pay that out 4 times per year. So that's going to get divided by 4. And then it's 4 times however many years, and the number of years would be 5. So if they look at your account 4 times each year, and you keep the money in your account for 5 years, that means that they will be evaluating your account and paying you interest 20 times. 20 times. So now we put this into our calculator, and we put it in exactly the way it looks. 2,000 times, put parentheses, 1 plus, and then you can use parentheses again if you like, or you can use your fraction bar, 0.045 divided by 4. But then you're going to need to use parentheses again, the bigger parentheses, raised to the 20th power. We put that in our calculator, and the end value, let's put that into our calculator. I'm going to show you putting it into my calculator because this might be either a long time ago in Algebra 1 that you did this problem, or I think it was $2,000. Was it $2,000 that we were investing? $2,000. So 2,000 times, and I have parentheses, 1 plus, and then I'm going to use my fraction bar, 0.045 divided by 4, end parentheses. Then I'm going to hit upper caret. That's that button that's next to the exit. That's upper caret. And then I have 4 times 5, which we already calculated to be 20. Press enter, and we will end up with $2,501.50. Money only goes out 2 decimal places. $25.01.50. Now, I hope that you enjoyed. I only answered that question right there. I hope you enjoyed the video. I hope that you also enjoyed the fly zone that we are under. The Air Force Base is sending their planes home right now. So it's just that time of the evening, and we just happen to be in the right location to hear those wonderful sounds. So I hope you understood, and if you have questions, always reach out, and we will see you in the next video. Have a great day.